As you can see, I've been knurling my knobs for a while now, and I think this technique is a great way to add that final finished feel to 3D printed buttons, knobs, and levers. This video is intended as an introduction to the technique, and while I'm covering it using Shapr3D on my iPad Pro, the same method could be used in whatever 3D design package you like. Let's start off with a simple circle. For my application, I'll need something 40 millimeters in diameter. Then I'll go ahead and extrude that up by 20 millimeters. So here we have the basic body of the knob. Now we're going to draw the outline of the cutting tool, which we're going to use to create the knurls. Here I'm using 4 millimeters as the knurl height. Now with a knurl depth of 2 millimeters, you'll notice that I've created an overhang angle of 45 degrees. Now depending on your print settings, this might work fine, but I've noticed that lately printing on 45 degrees can result as spaghetti, so I'll need to change that. It depends on the application, but sometimes I think shallower knurls actually look better, and it's also less pokey on your hands. So there you have your basic cutting profile. Now we're going to add an extra step in here that's really specific to Shapr3D, and I'll explain why later. So open up your 2D profile and just extend those cutting face lines to an arbitrary point. It really doesn't matter how long you go. Mirror them and then just close off the shape. Now if you don't do this, Shapr finds it pretty hard to union all the profiles together, so you'll find yourself subtracting individual cutting profiles from the knob, and that takes a while. Now select your extended profile, the central axis of the model, and hit the revolve tool. Instead of 360 degrees, I'm going to select 180 degrees. For the height, you'll remember that the knob itself is 20 millimeters and the cutting profile is 4 millimeters. So that's 24 millimeters in total, and that's how deep we want to revolve this shape. Now that we have one half of our 3D cutting profile, let's mirror it along the face of where we started the profile. And at this point, I find it easiest to just union the two cutting profiles together. Okay, now we have a complete cutting profile. Let's select it, and we're going to copy it and rotate it around the central axis. The question is, though, how far do we rotate it? You'll recall that the individual knurl height was 4 millimeters. The height of the knob was 20 millimeters, and that gives us a total height of 24 millimeters. If we take that total height and divide it by the individual knurl height, we get a value of 6. If we take the 180 degrees that we rotated the profile, divide it by 6, we get a total of 30 degrees. We need to rotate this profile 30 degrees. Now with this second profile, I'll join it to the first using the union tool. And now we'll repeat the process by selecting the entire profile, copying it, and rotating it about the central axis. This time, instead of 30 degrees, we'll rotate it by 60 degrees. Again, we'll union the new profile to the old profile, so we only have a single profile to work with. And this time, instead of 60-degree rotation, we'll rotate it 120 degrees. Take that last profile, copy it, rotate it about the central axis, again, just another 120 degrees. Once you're done with that, you can select the 3 profiles and union them all together. And there you have a complete cutting profile. The final step is to subtract the cutting profile from the original knob. This might take a minute because it has a lot of geometry to calculate. But there you have it, a finished knurled knob ready for printing. I'm printing this on my Creality Ender 3 V2 using Polymaker Matte PLA. I'm using a 0.4mm nozzle, 0.18mm layer height, 20% infill with 4 wall layers, and I printed it on a raft. And there you have it, a simple knurled knob.